so let's try number 13 from the example packet. Um, I'll tell you now, I haven't worked it out yet, so hopefully I get it right. Okay. Now, if you notice, I gave you 3 specific points. Those are the 3 same points that are going to be the important points on like a tangent or a cotangent graph. I'm not going to try and trick you with that. Not intentionally, anyway. So, let's aim for a tangent equation first, because it already kind of looks like tangent does. So, the general tangent graph is the main period that we tend to look at is centered around 0, and it looks like this, where this is at pi over 2 and this is at negative pi over 2. And remember, it goes through 0, 0, and then it goes through pi over 4 comma 1, and it goes through negative pi over 4 negative 1. The other thing is that so this is tangent, and then cotangent, which we'll also aim for at some point, looks like this. Oh, whoops, sorry, wrong way. Looks like this, where this is at pi and this point's at pi over 2, and then we still get pi over 4 comma 1, and we got 3 pi over 4 here now with negative 1. And so this is the graph of cotangent, and this is 0 here. Okay, so we need 2 different equations, one tangent, one cotangent. But if you notice, cotangent, we're never going to be able to get it to look like cotangent, but we will be able to get it to look like negative cotangent. Right? So now this point is really 3 pi over 4 comma positive 1, and this point is pi over 4 negative 1. So that, either way we can aim for those. So let's take a look at what we've got here. My vertical stretch, normally, if I'm looking at where the 1 and negative 1 are, that's a span of 2, but right now I'm going from negative 2 here to negative 6 here, so that's a span of 4. So my vertical stretch is really by 2. My period, if you look at the period, it's going from negative pi over 4 up to, what is that? That's 6 pi over 4, 7 pi over 4, 8 pi over 4. So this is 7 pi over 4 here. So that's a span of 2 pi radians. So the period's 2 pi. And the way that we get b is by taking the period of the parent function and dividing by b, or by r period. So the period of the parent is pi, and r period is 2 pi. So this has a b that's 1/2. Or you could think of it as a horizontal stretch by 2 over 1, right? Okay, so b's a half. B's a half. Let's see, what's next? Let's do vertical shift. So both cotangent and tangent are both centered along that x-axis. So y equals 0 is the center. It's the midline. But in this one, y equals negative 4 is the midline here, right? So the shift is really going to be 4 units down. And then it's a matter of, are we aiming for tangent or negative cotangent? So let's look at the horizontal shift if we're aiming for tangent. So tangent is centered at 0, 0, is centered at 0 here on the y-axis. This one's centered at, this is 2 pi over 4 and 4 pi over 4. So this one's centered at 3 pi over 4 here. So if I shift this 0 in tangent 3 pi over 4 units that way, then you'll get the correct tangent graph. Or, now the cotangent graph usually has an asymptote right here, the negative cotangent graph. Whereas the one that's in this picture has an asymptote at negative pi over 4. So if I take this asymptote that was at 0 and I move it to here at negative pi over 4, then I'm set. So that would be pi over 4 units left to get the negative cotangent graph. So let's write this out. If we do the tangent version, it's going to be a, which is 2, tan, b, which is 1/2. Let's see, it's going to be x or theta, whatever we're using here, x, and then it's 3 pi over 4 to the right, so 3 pi over 4 here, and then 4 down, so minus 4. Or it could be 2 negative, or negative 2, since it's negative cotangent, 1/2 x, and then pi over 4 to the left, so plus pi over 4, and then 4 units down. So either of those should work, and I'll double check and make sure they're right. Otherwise, I won't post this video.